Hello guys, welcome to NameTech channel. My name is Nehemiah and I'm very much happy to have you on board. This is lesson 11 on NumPy universal functions, and we are going to learn NumPy hyperbolic functions. But then before we begin, please subscribe to the channel if you have not subscribed, and to the returning subscribers, thank you very much for your continuous support. So guys, basically NumPy provides the universal function for sin h function, cos h function, and tan h function that takes values in radians and produces the corresponding sin h, cos h, and tan h values. Remember, an extension of h here is hyperbolic. Let me show you guys an example how to find, for example, the sin h value of pi over 2. So the first thing that you want to do before anything is to import the module. We are importing NumPy is np alias np, and then also let me now create convert. Actually, let me create now this let's find this sin h of this of the pi over 2. So before that, you use this np the alias for NumPy dot sin h, and then this is np dot pi over 2, and then now to find the this sin h value of this pi over 2, we are going to use this should be print, and then we are going to pass x. Then let me run the codes, and then here at the terminal, guys, you can see that this is the sin h value of this pi over 2. And so guys, let's now try to find the cos h value for all of the values in an array. Let's try with an array, but we are going to use cos h, not sin h. So first of all, let's import the module, the code library, which is NumPy, but then is np alias, and then let me create a variable, then let me assign it to np dot array. Then remember, array is defined using these these square brackets, and then let's begin with np dot pi over 2, comma, then also np dot pi over 3, and then also np dot pi over 4, comma, np dot pi over 5. Now here let's convert it to the cos h. Now let me do this. Let me create a variable and then assign it to np dot cos, should be cos h, and then we are going to pass a, and then to the print function we are going to pass also actually let's write print, then let's pass what this x, then let me run the codes. And so guys, basically this is how we can find the cos h values for all of the values in this array list. So guys, let's now discuss how to find angles. Now finding angles from the values of hyperbolic, sine, cosine, tangents, we just use the inverse of sin h, cos h, and tan h. That is arc sin h, that is also arc cos h, and arc tan h. Now basically guys, NumPy provides the universal function, that is arc sin h function, and also arc cos h function, and also arc tan h function that produce radian values for corresponding sin h and cos h, and also tan h values given. Now let's try to find the angle of 1.0. So first of all, let's import NumPy, but as np alias. And so guys, let's now discuss how to find angles. So guys, basically finding angles from values of hyperbolic, sine, cosine, tangents. Basically we just use the inverse of this sin h, cos h, and tan h. which will be arc sin h, arc cos h, and arc tan h. Now basically NumPy provides universal function that is arc sin h and arc cos h, and also arc tan h that produce radian values for corresponding sin h, cos h, and tan h values given. Now let's try to find the angle of 1.0 with the sine. Now first of all, we import what? We import the code library. We're going to import NumPy is np alias, and then also we are going to create a variable, and then let me assign it to np dot arc sin h, and then 1.0. Basically we're going to find the angle of this 1.0 value here. Then let's print this x. Let me run, and then guys, basically this is how you can find the angle of this 1.0. And so guys, let's now try with the arrays, how to find angles of each values in the arrays. So basically let's try to find the angle of all of the values in the, we are going to use the tan h values in the array. Let's try with the tangents. So first of all, we are going to import the NumPy module. NumPy is np alias, and then let me create a variable, and then let me assign it to this array, np dot array, and then let me create some values here, 0.1, perhaps 0.2, 0.5, and then let's now convert it to, let's find the angles here. We are going to create a variable, and then let me assign it to np dot arc tan h function to convert it into to find the angles basically. So and then now I'm gonna pass a, and then what I do here to the print function, let me say print x. Then let me run the codes, and then guys, basically this is how we can find the angle for all of the tan h values in this array list. So guys, basically this is all about NumPy hyperbolic functions, and I think you've understood the hyperbolic functions. Until next time, this is Nehemiah. Please subscribe, like, and share the video to your friends. Thank you very much.